Welcome to a new episode on the Technomora channel. We really hope you will enjoy watching it and invite you to tell us what you think of it by leaving your reactions below the video. And now, please allow me to present your host, Technomora.
Thank you, Julie. I'll take it over from here. So, dear viewers, the more observant of you will have noticed that lately in my videos, one of the main tools in my lab was missing. And this is my beloved Tektronix 2445 oscilloscope. It's a beautiful instrument. It has served me well in the past. It's a fantastic piece of equipment, but it seems to be suffering some problem. And until I managed to resolve the problem it's dealing with, I won't be able to use my favorite oscilloscope. What are the symptoms? Well, it started really months ago when I switched the oscilloscope on. The oscilloscope simply either wouldn't start at all the light indicators on the main panel would light on and stay on and nothing would happen. So the oscilloscope wouldn't go through its startup routine. So it would just hold and everything would light up except the screen, and that was it. Or it would start up, you could say, partially, and then it would stall. So and what did help sometimes was to switch it off and wait a minute, and then after a minute or so try to switch it back on again. And maybe after 2 or 3 times of doing this, the oscilloscope would finally start to work again as it should, let's say. But these unusual interrupts started to appear more and more frequently until, I'd say, maybe 6 weeks ago or 2 months ago, the oscilloscope just refused starting up at all. So no matter what I did, no matter how long I waited before pressing in the start button, the oscilloscope just wouldn't start up anymore. So there are 2 options left to me. Either I throw away and retire this oscilloscope and send it to transistor heaven, and have it scrapped or whatever, or I could try to repair it myself. Now, just a few words of caution here. I don't consider myself an oscilloscope expert, alright? An oscilloscope, and especially an oscilloscope like, for example, an analog oscilloscope like the Tektronix 2445, is a very, very complex and very specialized piece of equipment. So if you're thinking, just like me, of repairing your oscilloscope by following me in this video, you do so at your own risk. Okay, so don't forget, this is a very specialized piece of equipment. So there are a lot of electronic components inside of this, which can easily be damaged or broken. 2, this oscilloscope also has a high voltage section, alright, especially for its screen. And I don't think I need to warn you that high voltage can be deadly, alright. Thirdly, it is also AC powered, which in itself, of course, can also be deadly. But if you're not careful, you can cause all sorts of mayhem, okay? Not in the least fire, even explosions or whatever, shorts, you know. So, what I'm telling you is, it's fine by me if you follow me along with me in this video if you want to investigate or repair your oscilloscope, but again, you do so at your own risk. Alright, the very first thing to inspect is the fuse, which you'll find right here, and you use a large screwdriver to open up the fuse like that, and you measure it with a multimeter, which I did, and it turns out this fuse is okay. So the next thing you'll need is a Torx screwdriver and a lot of patience. So and if you ask me what kind of a Torx, well, there you go. I would estimate a 3mm or maybe a 4mm Torx. Alright, so here's a view of the underside of the oscilloscope. Alright. So now I'm not going to go in depth into these boards, simply because in my opinion the problem is not in these boards, but in some of the boards topside. Once inside the oscilloscope, I mean its innards topside, yeah, you can already see some of the most important boards of the oscilloscope. And one of the culprits that I suspect is causing the problem is one of these cards here. Alright? I'm going to go in depth which these cards are, but for the ones who are impatient, one of the cards, and specifically the one I'm pointing at, so this card right here, this card here, is labeled as card A2 in the service manual, okay? And I suspect the problem might be there, but it could also be topside on this card, and I think this is the card A3. Now, the very first thing that I measured was the fuse you see there, and this fuse checks out. Incidentally, these are some of the tools that you might need, okay? So a Torx screwdriver and 2 wrenches, miniature wrenches, okay? And these are rated in millimeters, so I think this is, let me see, 6 millimeter and was this an 8? Or, oh yeah, an 8. So a 6 and an 8 millimeter wrench, and a Torx screwdriver, and by the looks of it I would say 3mm Torx screwdriver. And of course a multimeter, a good multimeter to at least measure some voltages and some resistances. From here on you really should proceed with extreme caution. Okay, so I removed the cap which protects the AC input from being touched. Alright, and what we're looking at right here is one of the power transformer boards, you could say. So the raw unregulated power comes from this part here and then is connected through to the other board, this board here, to be chopped up and regulated. Okay, but that's not the tricky part. The tricky part is this. As you see in my other video, this board is connected to the board below it with some very specialized connectors, and in fact this one is a good example. Alright, and these connectors are very sensitive to mechanical stress and are very brittle. Yeah, they break easily, they are easily damaged. Okay, so what these connectors do in fact is connect one board through to the other, okay, via gold-plated contact. But to release this board you need to disconnect it, of course, from that one, and the way to do that is to very carefully, and I repeat very carefully, lift this connector, alright, away from the board. If you're going to do this with a lot of brutal force, you're going to ruin your oscilloscope. Okay, now this little connector here is retained by a little hook, a little plastic hook at the back, so you will need to lift that hook slightly in order to pull away the connector. Alright, so here it is. Now normally you don't need to pull it out completely, but I wanted to show you the little hook, so I lifted it out completely so that you could see the hook, right? So okay, I did not remember it as that, but you don't need to lift the hook, you actually need to push it in slightly. Alright, so when you grip the connector like this, you push on the little hook and then you pull, you rock and you pull the connector back, So I disconnected one back there, so this connector there needs to be pulled loose. Then there is another one down there that needs to be pulled loose, and then there's a third one which needs to be pulled loose, and which is this one here. There is one more very annoying screw down there that you need to release, and the space I'm talking about is really tiny and you can't put your hand into it, at least not completely. So very annoying. So you wonder, okay, what trick did you use to release the screw? Well, quite simply, I released the nut underneath, and the nut is located right here in the corner. Okay, and by releasing the nut from this side, I could actually release the screw from that side. But then you think, okay, now you're there. No, you're not there. You still need to undo this little part here, like this fork-like plastic holder, where the small print board, which sits here, is located in. And you undo that little fork by undoing this screw right here. So you think you're there, right? Nope, you're not. You still need to disconnect this eyelet connected to this braided wire here from that corner of the board on which the fan motor is fixed. Okay, and you need to undo yet another torque screw. So before you can lift out this board, you need to undo this screw as well. Alright, we're nearly there. To unmount board A3 from the chassis, you need to release 3 more torque screws from the row of power transistors you see over there. Alright, so the whole heatsink is connected to the chassis via 3 torque screws. Once you release those torque screws, you can, well, practically lift out the second power board. Now mind you, there are still a few connectors to pull loose. So this one and that one, and a few smaller ones down there. Alright? I forgot to mention actually, but if you're going to follow along with me in this video, you better take plenty of pictures, because it's quite easy to lose your way inside the oscilloscope. Okay, so make plenty of pictures, and as always, be careful with what you do, because you can really quickly damage stuff inside here, and really, believe me, you don't want to go there. If you need to identify the boards, okay, you can do so by reading in the upper left corner of the board, and you see right there where I hold my thumb the code A2. I know it's really difficult to read, but that's what it says, you know. Okay, so I don't know. Yeah, there you go, A2. Okay, and the other board is the board A3, and you see it right down there. Alright, that's board A3. Now, you might wonder, why is that important? Well, if you need to identify parts on the schematic, they will always refer to those codes. Okay, so A2 on this board and A3, which is this board. And on the board A3, by the way, is mounted the motor of the fan. Alright, so now that I have all the boards out, starts the tedious work of investigating. And I think, since I've got them out anyhow, that I'm going to replace all the electrolytics. Now that I have them out, why not? You could be excused for being a bit confused when I'm talking about a power or power supply board A2 or A3, and not knowing which board I'm talking about, either that board there or this board here. Alright? But the reason for the confusion is that the engineers at Tektronix decided that they would split the logical power supply units, being the regulator board and the inverter board, over, let's say, two physical boards, yeah, and in effect, even though either logical part, so being the regulator board or the inverter board, are not immediately, you could say, related to each other. So yeah, they were hampered by the physical length of a PCB, and they couldn't just fit the parts that would logically that should be logically located together on one PCB. They had to split it over two. Alright, so what happens is that the AC powered comes into the oscilloscope, and more specifically through this board here, alright, and through this part of the board, and is lowered somewhat and rectified, alright, and I'm guessing it's somewhere in the region of the output of the rectifier bridge, somewhere in the region of 90 volts DC, which is then filtered by two very large capacitors, yeah, and those capacitors are these two here. Alright, good. Now, after reading up on the fault tracking diagram of the Tektronix, it would seem that these two capacitors here, these filter capacitors, which are, by the way, 290 microfarad, 200 volts capacitors, you know, so these two here, alright, those two capacitors could be a possible source of trouble. So I've ordered two capacitors and I'm waiting for them to arrive, but in the meantime I also investigated other parts on very specifically this board, okay, and one of the things that immediately caught my attention is that if you'll go watch my first video on repairing the oscilloscope, you'll notice that there are a few very bad and really cheap, basically paper capacitors on this board, you know, like this one here, alright, which is a 2.2 nanofarad or 2200 picofarad capacitor, and then you have one of 0.01 microfarad or 10 nanofarad, and then you have one over there, and I can't read the value. Let me see. Okay, that too is a 2.2 nanofarad or 2200 picofarad capacitor. Yeah, and those are really not good capacitors, and actually I'm kind of astonished that Tektronix would use usually very high grade parts for their design and then use very low grade and very unreliable components like those. Yeah, it's a bit weird. If I were a bit cynical, I would say that that is part of a planned obsolescence. Yeah, but maybe not. Maybe they just sourced the parts and then got those from the supplier. Also, this capacitor here doesn't look super reliable to me. It's a 0.22 microfarad, 400 volts capacitor, non-polarized, of course. So I might replace those 4 capacitors that I showed you, and I'm certainly going to replace these 2, because everything seems to indicate that it is in fact these 2 capacitors who are loading down the whole power supply. Alright, so Tektronix in their service manual added a very specific chapter which is marked as power supply troubleshooting. Alright, and there's a whole decision tree diagram which allows you to identify possibly error regions of the power supply. Alright, and they do that by listing a few symptoms which allow you possibly to choose a different part within the diagnostic tree to locate parts that could be faulty. Now, what did sort of ring a bell for me was that they note here in the decision tree that capacitor 1021 and 1022 could be faulty. Not saying they are, but they could be. And those 2 capacitors are in fact these 2 here. Alright, I unsoldered the first capacitor that I suspected of being, well, not very good anymore, the 2200 picofarad, and this is the value I'm getting when I'm testing it. Focus. So 2946. So it's 30% over value, okay, over its rated value, and I'm going to replace it by this capacitor, which is a capacitor of 2200 picofarad, rated to 1 kilovolts, whereas that one was rated to 250 volts. Okay, let's measure the capacitance of the replacement capacitor. (2194 picofarad). While it's certainly recommended to use the exact same value for the replacement capacitor, the voltage rating is different, slightly different. Yeah, I would say it's okay to use a higher voltage rated capacitor in lieu of the old capacitor. So, and that's okay in my opinion. Now, how do I know that this capacitor is rated for 1 kilovolts? Well, if you look at the code which is printed on the capacitor, let's see, there you go. So it says 3A222, alright? And you should read that as 3A and then 22 times 2 and 2 zeros. so picofarad. Alright. The J code, I think, is the code of the manufacturer. 3A is the voltage rating code, and 3A means that it's rated to 1 kilovolts. I'll place a link down below the video where you can look up the voltage rating codes for capacitors. You need to put a fine layer of soldering tin on the leads of the component. Well, that's what I mean. Alright. So you see I wetted, so to speak, the leads of the capacitor with the tiniest amount of solder, which allows me to make the solder flow better around the leads. Alright. So, and that provides for better contact, obviously. And since it's also double-sided, the print board, you need to make contact on both sides anyhow. Alright, so I'm going to replace the last capacitor, or no, the one before last capacitor, and in fact it needs to go under the temperature switch you see here. So I'm systematically replacing the capacitors which are rated at 85 volts C instead of 105, because I reason that those will probably go bad sooner than the others. Now I just unmounted this one, which is a 220 microfarad 50 volts, and if you're wondering why I'm doing this, well, have a closer look at the spot where it was soldered. Don't know if you can see this, but right there, see this spot here? So that is actually leakage. I mean chemical leakage, okay? So apparently this capacitor at its anode leaked. Not hugely so, but it leaked. And in an electrolytic capacitor, that's never a good thing. So I mounted the new capacitors, the replacement capacitors for the original ones. An original one was like this, 290 microfarad, 200 volts DC, 85 degrees Celsius. Now these new ones are rated at 400 volts, 270 microfarad, and they are rated for 105 degrees Celsius. Good quality capacitors. I'm sure some of you would agree. But there's one little problem with these capacitors. Compared to the original ones, they have a slightly bigger diameter. Not by much, but I would say maybe 5 or 6 mil more than the original ones. And therefore the cap which encloses the capacitors doesn't seem to close up correctly anymore. So because, yeah, well, like I said, the capacitors have a slightly larger diameter, but that doesn't necessarily have to be a problem, because if you look at the side of the cap, what I actually would need to do is to cut away just one piece of it, so this piece here in fact, and this capacitor fits right neatly in between this space. It's almost as if the engineers at Tektronix knew that at some point in the future the original capacitors would have to be replaced, and they foresaw that the new ones would be slightly larger. Okay, noise alert. So if you don't like the sound of grinding plastic, then turn your volume down now. There you go. One side done, another to do. Alright, so I've got two options. So I took a look, and apparently cutting away this sidebar here is not enough. So there are two options. Either I cut away the two top bars, or I cut out a slot in the underside of the cup. Alright, so somewhere along this edge here. And I think I will go for the easier option. So I think I will cut away the two top bars. Obviously that will weaken a little bit the cover, but not to such a degree that it becomes too brittle. Besides, the two side cups, so this and that, are still firmly attached to the rest of the body of the cover. Alright, so unfortunately it ended up by me having to cut away the under part of the cradle, the plastic cradle as well. And I'm mocking it all up now, just to see whether the whole thing would fit once it's back in the chassis. And I think it will fit, but only just. Yeah, so it's going to be a tight squeeze. But either way, I think I can make it fit. The first organ I have to place back into the body, so to speak, is the A2 main power supply board. Alright? And you see all the power transistors over there attached to a heatsink. And the power board needs to be mounted back in there. And you can see where the heatsink of the power transistors was attached originally, down there. But what I might do is add a little bit of heat conductive paste to the back of the heatsink before I mount it back. So yeah, I might do that first, and when that is done, I need to reconnect it to the power inlet at the back. Alright, so yeah, give me a minute to reinstall that board, and then I'll follow up with an overlook. Alright, first you need to connect the power connectors, and there are 4 of them, 2 at the top, or I should say in the middle of the print board, and 2 down below, down there, 2 connectors at the bottom. Also, you need to connect these 2 connectors back to the board, and obviously you should connect them in the right order. Also, you should make sure that these connectors are connected to all the pins on the board. Okay, so don't make a mistake of shifting the connector 1 pin to the left or the right, or you might be connecting the wrong power to the motherboard, and that would be truly catastrophic. Next, we're going to install the shielding, and the shielding goes between the board A2, the supply board A2, and the larger board A3 that will be placed next to it. Now, remember, these connectors here, these true connectors, should never be bent. Okay, so these pins are very, very brittle. Okay, they can easily bend or break. So be extra careful with these. Now, before you insert the second board, so the board A3, into the chassis, make sure that these true connectors are pulled out until there's only maybe 3 or 4 mil left sticking out. And I can't tell you enough to be extra careful with these connectors. If you break these, then your options creak, yeah, without a paddle. Alright. Also, remember that there are these little plastic spacers you will have to account for. So there's one at the bottom down there, and there is one at the top, which temporarily you can leave unattached, or normally there's a screw holding it down, but I left it unattached, okay, because the board A3 will need to be clamped into it as well, and it's a bit tricky to do. As you can tell, there's a little pin that needs to go through the board, and then there's a clamp on top which needs to hold the board onto the pin. Alright, so that's why I'm leaving it for the moment unattached. Also, there should be a little spacer block like the one you see down there, which is attached to the chassis with this screw here. Alright, so, and then in the end, I will also have to attach this plastic spacer here. Alright, and if I remember correctly, the plastic spacer goes in like this. Alright, there's a little black tab here which fits into a little cutout in the metal. Alright, so yeah, be methodical once you're placing back everything, because if you make a mistake now, yeah, you'll be in deep trouble. Next to go in is the refurbished power supply board A3. Alright, now before you mount it back, do check that all the connectors, especially the connectors for the fan, are reconnected up there and up here, and that the high voltage shield is mounted back as well. There are 3 screws, one there, one over there, and one here. And that all the screws that hold down the capacitors and the fan are all tightened down properly. Okay, so also you'll notice that the shield has cutouts, and the cutouts correspond exactly with the true connectors. Alright, so there are 4 cutouts in all. So you can't really miss, alright? So if the cutouts align with the true connectors, you know you're right. Also remember to put in the spacer plastic tab you see here. Alright. So yeah, this is the hardest part of the operation. Next to go in is the refurbished power supply board A3. Alright. Now before you mount it back, do check that all the connectors, especially the connectors for the fan, are reconnected up there and up here, and that the high voltage shield is mounted back as well. There are 3 screws, one there, one over there, and one here. And that all the screws that hold down the capacitors and the fan are all tightened down properly. Okay, so also you'll notice that the shield has cutouts, and the cutouts correspond exactly with the true connectors. Alright, so there are 4 cutouts in all. So you can't really miss, alright? So if the cutouts align with the true connectors, you know you're right. Also remember to put in the spacer plastic tab you see here. Alright, so when you want to put the board A3 into the chassis, you need to do it at an angle. Alright, so you need to slide it in like this, and once it's completely in, you can move it back parallel with the shielding and the board A2. Now do notice that little plastic tab down there. Okay, I'm shining my laser at it. So that plastic tab is important because the board A3 needs to rest in the outer slot of that plastic tab. Also, always keep handy a flashlight, okay? That is definitely not a luxury, alright? So anyway, I placed back the board A3, and the shielding between the board A2 and A3 is also back in place. I don't know if you can see it, but down there the board A3 is resting on the little plastic tab. You just about see it there. Let's see if I can shine some light on it. There. Alright, so, and as you can tell, the shielding can never make contact with either board because there are little plastic spacers mounted into it. Now, remember I told you that you need to slide in the board A3 into that plastic tab right here. So I left it unattached. So because then I have a little play still, for the very simple reason that I'm going to slide in back these contacts. And when I do, I will slide them back in evenly, like this, and make sure that they make proper contact, and this is an operation you better take your time doing, alright, because even half a mil can make a difference between breaking or bending them, or making the operation go all wrong. But there you go. Voila. Alright, all the true connectors are in place. The little hooks are back, hooked inside their little catch holes. And remember, there are 4 of these connectors, 2 at the very top of the board and 2 down there. Alright, so there's 1 over there and there's 1 over here hiding behind these wire looms. Okay, so yeah, so there it is. Okay, so remember, be gentle. Now, here you have an overview of how the boards should fit inside the cabinet. Alright, another important detail is that you need to attach the grounding of the shielding over there. Remember that little metal spacer we had to put in on the right? Yeah? Well, that tab or that eyelet should be attached with a Torx screw to the little spacer on which I'm shining my laser. You can just about do it from the opening of the fan, with a Torx screwdriver like this. Alright, so it's just about feasible, but again, be gentle. Before we mount the next board, the final board, so this one, you need to install a little spacer, and I'm talking about this spacer here. Alright, so you need to install that spacer first, and it's held by a little screw at the back, and on the spacer itself there's a little plastic tab that fits right into this hole here. So don't forget to mount the spacer, because this is essential to keep the last board in place. Alright, I put in the last board in place, and I slid it into its little holder right here, so which is like a little plastic tab. Alright, and I'm double checking to see whether it's not making any false contact with anything, and it isn't, and it's clearing. It's just about clearing the new capacitors, but only just. I mean, there's maybe only 2 millimeter space, yeah, which is okay. I mean, I would have been happier had there been a bit more clearance, but it's okay. Alright, so now you need to plug in the little board on this side. Alright, so you need to slide this flat cable here through that opening over there, and then connect it up here. Alright, so that's one thing. The other thing you need to do before we can start work or test the oscilloscope is to plug this back in, and that little plug goes through that opening right there. Alright, I fished the wire through that opening patiently, without forcing it too much, and now we need to plug it back onto these pins here. So make sure you cover all the pins, alright? So don't miss a row of pins, because that could really put you into trouble, alright? So take your time to check and double check all the connections before you fire up anything. Alright, I fished the wire through that opening patiently, without forcing it too much, and now we need to plug it back onto these pins here. So make sure you cover all the pins, alright? So don't miss a row of pins, because that could really put you into trouble. I did mount back the fan head, alright, just as a visual clue whether everything is getting power. And yeah, you're going to discover together with me whether the oscilloscope functions or not. So yeah, well, here it goes. Alright. Well, it would seem the oscilloscope functions. I mean, the fan is working. I haven't seen any sparks or smoke, and there you go. The screen seems to work. So give me a moment, I'll attach a probe, and then we'll see whether the oscilloscope functions normally or not. Alright, I'll show you in a minute the signal sensing on the oscilloscope screen. There's just one detail that's really bugging me. That's the rattling of the fan. So it's not extremely loud, but it does have a slightly annoying rattle. And I'll have a look whether I can fix that or not. Now, either way, I connected up a probe to the oscilloscope, and when I touch the oscilloscope's probe, it's picking up the 50 Hertz noise of the environment. I think you can see it, right? So, okay, this is not an exhaustive test by any means, but it does mean that at least the input 1 is functioning right here. I haven't tested input 2 yet, and the other 2, 3 and 4 either, but I'm reasonably pleased with the result, okay, and the screen is bright, and everything seems to work. The menus seem to work. The boot up test seems to work. Everything seems normal to me. So what I need to do now is to bolt put it all back together again, put it back in its enclosure, and give you one final look of a refurbished Tektronix 2445. In case you're wondering how many electrolytics I replaced in the Tektronix 2445, well, I counted them. There are 17 of them. Alright. I also replaced a few capacitors of the type that are infamous for failing. These are in fact paper caps disguised as mylar capacitors, but in fact these are paper caps. So if you find these inside your oscilloscope, by all means do replace them, okay, because these are notorious for failing. I also replaced this mylar one. I don't think this is a paper cap or one disguised as one, but I replaced this one anyhow, and it can't hurt, in my opinion, to replace this one as well. So, like I said, 17 electrolytics, all rated at 85 degrees C, alright, and 3 paper caps and 1 mylar one, alright. So there you go. If you're going to replace the capacitors in your oscilloscope, be aware that it will take, if you do the job well, it will take you at least 2 days, okay, because this is not something you would do in a rush. If you're curious to know how much power the Tektronix draws once it's repaired, well, it would be around, I'm estimating 66 watts, alright, or thereabouts. So if you're curious how much power a well-working Tektronix 2445 uses, yeah, so 224 volts, 300 milliamps, or there around, is around about 66 watts. While I was putting back the oscilloscope together, I noticed this little label here, and it would seem the oscilloscope got its last calibration almost day for day 16 years and 1 month ago. Unfortunately, I do not have the necessary equipment to calibrate an oscilloscope. Neither do I have the knowledge nor the inclination to do so. But who knows, the day my channel hits, I don't know, 10,000 subscribers or so, I might just give this oscilloscope a calibration, which I imagine is not cheap. But I would almost say I love my oscilloscope. I mean, this Tektronix oscilloscope, except for the problem for which I fixed it now, was always reliable and easy to use. And okay, I have a Hewlett-Packard oscilloscope, which, by the way, would need a new CRT, because this one is a bit tired and not so bright anymore. but aside from the defect my Tektronix had, and which I managed to repair, now I was always happy with my Tektronix. I mean, it's an accurate, easy to use, and beautifully put together piece of equipment. I mean, granted, in this day and age where everything is digital, a semi-analog oscilloscope like this one is a bit outdated, you might say. But hey, I refurbished it. You might even say I repaired it, and now it seems to work all right. So, in the coming videos, I will switch back to using my trusted Tektronix 2445 for any coming restorations. So I hope you enjoyed watching this video. Please do leave a comment below the video if you so wish, or even ask me a question if you would. One last parting quip I would say before I finish the video is, if you're going to do what I did, and you're going to follow along with this video, do be careful. There's a lot of high voltage inside of this piece of equipment, and the possibilities for unrepairable damage are numerous inside of the oscilloscope. So beware, inside there be dragons. Alright, so be careful. Anyway, I hope you enjoyed this video. Please leave me a comment and give me a thumbs up if you liked it. Thanks for watching.